Okay, differential equations, worksheet 2, number 1. First thing, separate the variables. Okay, the first thing that we're going to do is we are going to bring the y squared over to the left, and then the dx has to go over to the right. So we are going to multiply both sides by dx over 1, and then we are going to divide both sides by y squared. All right, y squared. All right, I'm going to try to do that in 2 steps. So over here, the dx's are going to cancel. So we have 1 over y squared dy. On the right, the y squareds cancel, and we have x dx. So that's looking pretty manageable. The only thing that we're going to want to do is we're going to rewrite this, because I don't know how to take the antiderivative of a fraction, but I can move this up to the numerator, and that exponent will become a negative. So I'm going to rewrite the left side, and it's going to look like this. Y to the negative 2 dy is equal to x dx. Okay, so now my variables are separated. Now we integrate both sides. All right, the antiderivative of y to the negative 2 is going to be y to the negative 1 over negative 1. We add 1 to the exponent. So y to the negative 1 over negative 1. All right, on the right, the antiderivative of x to the first is just x squared over 2. We write it as 1/2 x squared plus c. All right, so now what we have to do is we have to rewrite this, because we can't find our c if we have a negative exponent. So we're just going to simply rewrite this. All right, so we are going to move the y to the negative 1 down to the bottom, and it's going to become 1 over y to the positive 1, and there's still a negative out front because that negative is there. All right, so then it is equal to 1/2 x squared plus c. That is as far as we need to go. Just get the term with y in it by itself. Now we simply plug in our point. So now we're going to plug in our point. 0, 2. 0 is our x and 2 is our y, so it looks like this. Negative 1 over y, which is 2, is equal to 1/2 times x squared, which is 0, plus c. Okay, and now we just solve for c. You can see that this is all going to go to 0, so we're going to have c is equal to negative 1/2. All right, and that's all you need to tell me. All right, let's go on to number 2. Okay, to separate the variables, we have to multiply by dx to get the dx on the right, and we also have to multiply by y. So we're going to multiply, I got to get the dx over here, and then we also have to multiply by y over 1. Okay, I'm trying to do that in 2 steps. So these are going to cancel. On the left, we have y dy. And on the right, we still have the 0.25, but the y's here cancel. So we have 0.25 x dx. So our variables are separated. Now we integrate both sides. On the left, the antiderivative of y is y squared over 2, so we write it as 1/2 y squared. On the right, I'm going to write 0.25 as 1/4, because that's going to help me when I bring the antiderivative of x down. The antiderivative of x is x squared over 2, and we write that as 1/2 x squared plus c. Now we're going to leave the left alone, 1/2 y squared, and we're going to simplify that. That's going to give us 1/8, tops and bottoms, x squared plus c. And that is as far as you have to go there, because your term with y in it is by itself. Now we simply plug in our point to find c. So we're going to plug in 10 for x and 4 for y. And it looks like this, 1/2 times y squared, which is 4. On the right, we have 1/8 times x squared, which is 10. plus c. And now we just go to work and solve that. Okay, over here, 4 squared is 16. Half of 16, that gives me 8. All right, on the right, this right here gives me, let's see, let me slow down here, 1/8 times 100 over 1, because 10 squared is 100. Now if I multiply tops and bottoms, I get 8 on the left still, but I get 100 over 8 plus c. Now I'm just going to change that to a decimal. 100 divided by 8 is 12.5 plus c. And then if I subtract 12.5 from both sides, I'm going to squeeze it in here, minus 12.5, minus 12.5. Hey, c is equal to negative 4.5. And there's your c value. Okay, let's go on to number 3. Okay, to separate the variables here, we're going to multiply both sides by dx to get the dx to the right. So multiply by dx, and then of course this y squared has to move over, so we need to divide both sides by y squared. So 1 over y squared. On the left, these cancel. We have 1 over y squared dy, and on the left we have the y squareds cancel, and we have 10x dx. All right, so now we're ready to integrate both sides. Before we can integrate the left, we have to rewrite that because we don't know how to take the antiderivative of a fraction, but just like we did before, we can move this upstairs, and that becomes 1, or it's not, excuse me, that becomes y to the negative 2 dy, and then the left stays this, or the right stays the same. Okay, hopefully you got all that. All right, now we're ready to take the antiderivatives. The antiderivative of y to the negative 2, if we add 1 to the exponent, we get y to the negative 1 over negative 1. On the right, 10 comes along for the ride, and we get 10x to the second over 2 plus c. Now let's simplify this. Again, this negative is going to come out front, and this whole thing is going to move downstairs, and it's going to become positive exponent of 1. So it's going to look like this, negative 1 over y to the first. On the right, the 5 and the 10 divided by 2 becomes 5x squared plus c. And that is as far as you need to go. Now we're ready to plug in. All right, so I'm going to go up here. We're going to plug in 3 for x, and that is 0.2 for y. All right, so let's go to work. We have negative 1 over y, which is 0.2. On the right, we have 5 times x squared, which is 3 plus c. Now, on the left, if we take negative 1 and we divide it by 0.2, we get negative 5. So that becomes negative 5. On the right, the 5 comes down. 3 squared is 9 plus c. So we keep going. Negative 5 comes down on the left. 5 times 9 is 45 plus c. And now we're ready to just subtract 45 from both sides. And that gives us a c value of negative 50. That's a fun one, huh? All right, the last two. Number 4. Okay, to separate the variables, this dx has to go over to the right. So we're going to multiply both sides by dx. I put a dx over here. And then this whole thing here, y minus 1 squared, that has to move over to the left. So I'm going to divide everything by y minus 1 squared. And that has to be in the denominator because we're dividing. So 1 over y minus 1 squared. All right, so let's clean that up. These cancel out. So I'm left with, on the left, 1 over y minus 1 squared dy. And on the right, these guys cancel out, and I just have x dx. Now, on the left, I have a fraction. So I'm going to move this whole thing up to the numerator, and this 2 is going to become negative 2. So I need to get rid of that fraction. So I'm going to have y minus 1 all to the negative 2 dy is equal to x dx. The reason I rewrite this to this is because I know how to take the antiderivative of this. And now I'm ready to integrate. Now, to take the antiderivative of this fun thing right here, that is a composite function. There is an outer and an inner function, so that is going to be u substitution. Already, and then of course on the right, that's just going to be a power rule. So we're going to go off to the side here. Here I go. Come with me. All right, so we're going to take y minus 1 all to the negative 2 dy, and we are going to do u substitution. So the first step, u is my inside function. My inside function is y minus 1. So that's the first step. The second step, u becomes du, and we take the derivative. The derivative of y is just 1, and then the derivative of negative 1 is just 0. So our derivative is 1, and then of course we toss dy on the end. Okay, now we're going to go diagram. All right, I'm going to highlight it. This right here, that's going to become u. So we are going to rewrite this whole piece as u to the negative 2. So what's left? dy. dy has to be by itself here. It already is, so there is no adjustment needed. Okay, now we keep going. Step number 4, we rewrite everything. Again, this piece becomes u to the negative 2. And right here, dy is now equal to du. So it's not a bad one at all. All right, fifth step, we finally get to take the antiderivative. To take the antiderivative of this, that's the only thing there to take the antiderivative of, because the notation is going to drop out. That is a power rule, so that becomes u to the negative 1 over negative 1. And then if we simplify that, the negative, this negative here goes out front because we're dividing by a negative 1. Okay, so then it's negative u to the negative 1. And now we're ready to plug in u, and u is y minus 1. So that is the antiderivative of the left-hand side. So now we're going to go back over here. The antiderivative of that fun thing there is negative y minus 1 to the negative 1. And on the right, the antiderivative of x, of course, is just good old power rule, 1/2 x squared plus c. Alrighty? And honestly, I'm going to rewrite this side because I can't solve for c if I have a negative exponent. So this negative is going to come down, and I'm going to put 1 over, and I'm going to take this whole piece and I'm going to move it downstairs, and that negative 1 is going to become positive 1. So I have negative 1 over y minus 1 to the positive 1. And that allows me, to, of course, to be able to plug in my point to find c. So this is as far as you need to go. All right, now we just plug in. All right, I'm going to plug in my point. My point is 0, negative 1. This is my x 0, this is my y negative 1. So it looks like this. Negative 1 over y minus 1. Y is negative 1, so negative 1 minus 1. And then it's equal to 1/2 times x squared, which of course is 0 plus c. Okay, so now this works out pretty nice. Let me go up here. Okay, this goes to 0 right here, so 0 plus c, that gives me c on the right. All right, over here on the left, we have a negative out front. So we have a negative, and then on the bottom, negative 1 minus 1, of course, is negative 2. So a negative and a negative is a positive. So hey, c is equal to positive 1/2. All right, there's number 4. That was a fun one. Okay, last one. Alrighty. Okay, the first step is to rewrite this left side because we don't have any differentiables up there. So y prime is the same as dy over dx. So rewrite that, and then the right-hand side comes down, so that's 1 minus 0.2y. Okay, now, in order to separate the variables here, this is tricky. On the left-hand side, we have two separate terms and a subtraction sign in the middle. When we separate the variables, we always want something times dy on the left, and over here we want something times dx. So when you have two separate terms over here, it really makes it hard to separate the variables. So what we can do is we can factor this right-hand side so that you have multiplication, only multiplication on that side. So on the left, I'm just going to leave that alone for a minute, dy over dx, but on the right, I'm going to factor out 0.2 because 0.2 goes into both 1 and 0.2. So again, our goal is to get this to be all multiplication over here, something times something. So if I factor out 0.2, if I divide this 1 by 0.2, I get 5. And then if I divide 0.2y by 0.2, I just get y here. Now that is all multiplication over here. That makes it easier to separate the variables. All right, so now let's separate the variables. We are going to multiply both sides by dx. So the dx goes over to the right. And then I'm going to divide, well, let's write that out. Let's not get ahead of ourselves here. So we have dy on the left. On the right, we have 0.2 times 5 minus y times dx. Again, we have all multiplication here. Now, this has to move over to the left, so we are going to divide by 5 minus y. We're going to divide by 5 minus y. So now, we're going to rewrite this. We're going to pull that out front, 1 over 5 minus y dy, and it's equal to, these cancel, 0.2 dx. Okay, so now our variables are separated. Now we integrate. Now, because this is y to the first, we can use our antiderivative of 1 over y. If you remember, the antiderivative of 1 over y is ln absolute value of y. So again, because this is y to the first, we can use that. The antiderivative of 1 over 5 minus y is simply ln absolute value of 5 minus y. And again, that works because this is y to the first. On the right, that's just a power rule. The antiderivative of 0.2 is just 0.2x plus c. Okay, now we have to get rid of ln, so we exponentiate, make that e the base. These cancel. We have the absolute value of 5 minus y on the left. On the right, of course, we have to get c out of the exponent, so we rewrite that using exponents, and we get e to the 0.2x times e to the c. This is our c, of course, right here. Okay, so now really, let's make our life easier. That's as far as you need to go because you've got the term with y in it by itself. All right, that's all you need to do. Now we can plug in our point. Luckily, I gave you a very easy point, 0, 0. So on the left, we take 5 minus y, which is 0, the absolute value, of course. On the right, we have e to the 0.2 times x, which is 0, times c. Again, e to the c is same as c. These are both constants. Now on the left, hey, 5 minus 0 is 5, and the absolute value of 5 is 5. On the right, this whole thing here goes to 0. E to the 0, of course, is just 1. So that becomes 1 times c. So c is equal to 5. And you're done. All right, hopefully this helped. 4 and 5 are definitely tricky. Please go through those on your own step by step. Take care, pre-calc.